Hello everyone. Today we're going to talk about lesson 1.2, which covers linear measure. Our objectives will be to be able to measure segments, using a ruler, and then calculate with given measures. So, first let's define a line segment. Okay, a line segment is part of a line with two endpoints. So a line segment, let's just talk here. If we had a line AB, so if this was line AB, of course lines don't have endpoints, they go on infinitely in either direction. Okay, so a line segment would just be the part of the line with endpoints at A and B. And so notation wise, to use a line segment, we just use a line above the 2 points A and B. We don't need the arrows to show that it goes on. Okay, so the difference, notice the difference again between line AB and then segment AB. Alright, segments have endpoints. So let's talk about metric measure. So metric measure, we talk about meters and centimeters, millimeters, things of that nature. So find the length of AB using each ruler. So here the ruler is only broken down into centimeters. Okay, we see that it's clearly past, so segment AB here is clearly past 3 centimeters, but not quite to 4. So we've just got to estimate, and I would think that's past the halfway point, so let's maybe estimate to be 3.7 centimeters. So that's as accurate as we can get with the given ruler here. On example B, the ruler that we're using breaks it down into millimeters, which are, a millimeter is a tenth of a centimeter. So we break this down into 10 small segments. And here we can see this is clearly past 3 centimeters again. That's 3.5, 3.6, and 3.7. So here AB, it's pretty clearly 3.7 centimeters. Okay. So these next couple of problems, just some guided practice. If you're there at home, go to the junk drawer, find a ruler, and measure the length of a dollar bill. Use centimeters, so rulers usually have an English side that measures in inches, and then they have a metric side that measures in centimeters. And so do that in centimeters for 1A, use a dollar bill. Maybe find the measure of a pencil. Don't use millimeters, just use centimeters. Okay. And then here use the picture to find the length of CD. Okay. Let's go back real quick and let's talk though about the difference between centimeters and millimeters. So just for a second, let's highlight example B because this has a really good example of it. So we talked, or I mentioned that this is in centimeters, but then it's broken down into millimeters. So each little mark here along the ruler is a millimeter. Again, there are 10 millimeters per 1 centimeter. So as I go to 1 centimeter, that is equal to 10 millimeters, which we just use with mm. And so if I go to 2 centimeters, that of course is 20 millimeters. 3 centimeters is 30 millimeters. So if we thought about AB in millimeters, we had 3.7, so we had 30 millimeters. 1, 2, 3, 4, 5, 6, 7. So 37 millimeters. So the metric system, it's pretty easy to convert between centimeters and millimeters and even meters. Centimeters means there is 100 centimeters per meter. Okay? So I just wanted to talk about that. You can kind of convert in the metric system pretty easily. They all work in units of 10. And so if you really did want to take a look at 1B, you probably could measure the length of your pencil using millimeters now. Alright, let's continue then. So standard measurement, or the English system here. So find the length of CD using each ruler. So as you can see, it's not quite as simple as the metric system. Each segment here is 1 inch, so this would be 1 inch, and then that is broken down into a half of an inch, and then even more so into a quarter of an inch and 3/4 of an inch. So that's how these are broken down. Example B, it clearly breaks it down into eighths and then even 16ths as well. So got to work a lot more with fractions when we use the standard measurement. Okay, so CD here is, let's see, it's 1 inch, and then it goes, that would be a quarter. So 1 and 1/4 inches CD. Okay, and in this measure, even though in example B they break it down, so there would be our 1/4 again, and then they go eighths and 16ths. Well, it's still, see, D just lands right there at 1 and 1/4 of an inch. Anyway, so no change there. Okay. Key concept here: betweenness of points. Okay, point M is between points P and Q if and only if P, Q, and M are collinear and PM plus MQ equals PQ. So the idea of betweenness is that M falls between P and Q only, or if and only if PM plus PQ, or excuse me, MQ equals the whole segment PQ. Okay. And this PM plus MQ equals PQ is an example of the segment addition property, which we will use quite a bit here throughout the rest of the lesson. So the segment addition property, it just gives us that if you add the two smaller segments, so in this example, if we look at example 3, segment addition gives us that EF plus the next part, FG. If you add those two small segments together, they add up to make the whole segment EG. And so you should be able to find EG because you're given the measures for EF and FG. So EF is 2 and 3/4 plus FG, which is 2 and 3/4. You would get EG to be 5.5. Okay, 3/4 plus 3/4 is 1 and 1/2, so 4 plus 1 and 1/2 would give you 5.5 inches. Okay, let's continue. Find measurements by subtracting. So here we've got that. We're trying to find AB. So segment AB is just, it's that piece. We're looking for AB. Okay, using the segment addition postulate, AB, that segment, plus what's the other small piece of this, plus BC would equal the entire segment. In this case, the entire segment is AC. So we can use substitution. Okay, of course AB is what we're looking for, plus BC, we're given that measurement is 5.8 meters, equals AC, the entire segment, which we're given is 13.2 meters. So solving this equation for AB, we find that AB is equal to 13.2 minus 5.8, 7.4. If we're given units, we need to use units, so 7.4 meters. Okay. So write and solve equations to find measurements. So find the value of A if, A and XY, if y is between x and z. So this part of the problem, y is between x and z, gives me this relationship here. They're all collinear, so that means they all lie on the same line, which I didn't do a very good job of drawing that. Okay. So they're all three collinear, and y falls between x and z. Okay, so we have that relationship, and then it tells us xy is 3a, so we'll go ahead and label xy as 3a, and then xz, so the entire segment xz is 5a minus 4, and yz is 14. So segment addition tells us that xy plus yz equals xz. So xy, we're just substituting. Xy we were told was 3a. Yz, so xy plus yz is 14, is equal to xz, which was the whole segment 5a minus 4. And we just want to solve this equation for a. Solving for a. Get all of our a's on one side. So that gives me 14 equals 2a minus 4. Add 4 to both sides. We've got 18 equals 2a. So here we see that divide both sides by 2. A is 9. We were asked to find a and xy, so now we just have got to plug in. We were told xy is 3 times a. So xy, 3 times 9, 27. Alright. Last idea here. Segments that have the same measure are called congruent. So we use the word congruent to define segments that have the same measure. Okay, and so symbolics, we say two measures are equal, we use the equal sign. So that's equal measure. And if we're going to say segments are addition, or excuse me, if we're going to say segments are congruent, we use this symbol, which means that they are the same size. So we have our congruent symbol and we have equal measure. Okay, your assignment. Of course, we're working geometry assignment here, 1 through 9 on page 18. We're going to do all of those. Okay, and we'll do those in class tomorrow. So thanks for watching. Have a wonderful afternoon.